Alrighty then, folks. Welcome, welcome. Let's get the visual out of the way there. How is everyone today? Can you hear me all right? Is the volume all right? Is the music all right? Everything seems to be pretty good here on my end. Please let me know if that is not the case out in the wide world. Hey Tutu, welcome back. Good afternoon. Well, it's pretty much evening here already, but volume and music are okie dokie. That's good. Good to know. Good to know. And sorry for the slight delay. Well, it actually wasn't that bad. Had some suddenly some things to take care of here before we started, but seems to be almost on time. So today we're gonna continue. This is sort of a follow-up stream to the last one. So I've been working on code hot reloading for this week basically. I think it was on Monday maybe that I started doing it. Was it on Monday? I think it was February 9th. Yeah, that was Monday. That I started looking into hot code reloading for my Zig C++ hybrid code base, with the intention of making the Zig code hot reloadable. And it's been a whole thing. It was kind of turned out to be more complicated than I thought. But it is starting to show some promise. So I figured, yeah, let's do this. Saturday night. What better thing than do a little demo for you guys. So if you weren't here last time, let's just quickly look at what we drew here. My beautiful handwriting with a mouse here. So first of all, we have this gamey thingy here, Traction Point, the game I'm building, which is running on top of a C++ game engine. But the gameplay code, pretty much all of the game code, is written in Zig. And because it is written in Zig, it is sitting in a DLL. Hey Arcane, welcome back. So because it is written in a different language than the actual game engine itself, it is in a DLL. So we can see here we have the exe right here, Traction Point. We have basis.dll, which is the core game engine. And then we have means game, which is the actual game code, which is a DLL, which is written in Zig. And then I drew some other, potential mods. We a few streams ago we did a little C3, made a mod in C3, and the one before that in Odin, and there could be a one in Jai or something, whatever down the line. Long time no see. Yeah, absolutely. Absolutely. I don't actually remember. It was last year, I'm sure. But yeah, it's been a while. Is the reload operating system dependent? No, not really. No. I mean, I'm on Windows, as you can probably tell. I'm on Windows right now. I don't think there's anything particularly operating system dependent here. We do have a little bit of. Actually, I'll get into it in a little bit. I think we wrote some code last time, which actually makes it operating system dependent currently. But that's basically like one line of code, which gets the exe folder path. Yeah, here, make Zig app library hot reloadable. This thing we wrote last time, and there's just a piece of code here. It's not a single line of code, actually. It's a few lines of code, but it's just get module file name, which just gets the exe path. So yeah, like in theory, it is operating system dependable. But if you can get the exe file path, which I'm sure you can do on Mac and Linux and whatever, the actual reloading is not operating system dependable. No, nothing like that. Anyway, so yeah, this DLL here. Let's make this like a slightly smaller. It's very thick. This thing here, this DLL. We want to make this hot reloadable. Hot reload. And I can't draw with a mouse for the life of me, as I'm sure you can tell. So we're not gonna hot reload the C++ code, just the actual game code, but that tends to be the code that you actually kind of want to, you know, hot reload anyway. At least that's been my experience so far. This, of course, being C++, I can make this slightly larger for you guys. Let's do it like make like 120 or so. This being C++, this is the engine code, and then we have the actual gameplay code, which is, you know, just looks like this. So this is the kind of stuff that we want to actually hot reload here. And so let's have a look. How does this actually work? If we go into, here we have the game running. I just muted it so we don't hear any music or sounds or anything like that. So if we go into something that we can actually like sensibly hot reload here. Let's go into sandbox mode, because this thing actually has a custom UI element here. This thing that I call the sandbox level carousel. Looks like this. This is essentially just one big UI element, which we can see if we go into new window. Means UI. And then we go into the sandbox menu. We can see that we have something called the level carousel, which is a canvas. If we enable these borders here, you can see that okay, this thing is just this entire thing is one canvas, which is called level carousel, and it is being rendered from code, because canvases are essentially just that. They're just a canvas with a name, a size, and a position. Level carousel. So let's go and have a look where can we find level carousel in the Zig code. Here we can see sandbox level carousel widget. Right? So as a kind of demonstration for you, let's see what this thing actually does here. We have some setup code, sandbox level. There's probably going to be a render function somewhere. Here we go, render callback. So this is the kind of thing that is actually really nice to do. You know, hot reloading with, because as you can see, we have all kinds of like just magical numbers put in here to make this thing look nice. But let's just try something simple here. What do we have? Sandbox loading, sandbox levels. No sandbox level found. And then we're drawing the actual levels in a for loop. And some place here we have like name and description. So that would be like these two guys. Okay, we have some questions here. Does your UI handle arbitrary window resizing? It does, yes. However, currently I'm sort of forcing the UI to be a certain aspect ratio. Let's see if we go into UI manager. You can see here set fit mode. So fit mode is set to contain. You can also set it to fill the entire screen, getting stretched if needed. Contain is the UI will maintain its aspect ratio and be scaled to fit inside the screen. And then cover, which I actually haven't implemented yet because I never needed it. It will be clipped. So basically, like it is currently, it looks like this. It just like puts it keeps the aspect ratio of the UI, which is something that like it might make sense to let it kind of. That makes sense to let it fill the screen for some of the more obscure resolutions out there. The problem is though that some of these like designs they don't really work, you know, all that well if you just stretch them. So currently I have it set to that fit mode there. Let's do window.set size 1080 to put it back to the 1080 resolution. So I was thinking here, okay, we would change some of these things here. Kings and Castles is the name, and this is the description. So here if we go to let's see, where do we have it? It's up here somewhere. Here we go, name. Okay. Font size, right? Just make it, you know, double like this. And then I hit Control-Shift-B, build debug. And we can see that, again, since I'm on Windows, this phase, LLVM emit object, this is annoyingly slow currently. So the SIG folks are working on a self-hosted compiler, which should be much faster. But currently this takes like, what was that, like 4 seconds or something to build? And okay, nothing changed because I don't have a file watcher set up. So that's something that I'm going to want to have. But we can have, this is the hot reload debug menu item, which we actually added in the last stream. Look at that. It just works. We can make it glow text color. We can just make this like basis color green, for example. And again, we do a rebuild. And I think the limiting factor here for how handy this thing is like Zig's compilation speed currently. Obviously, I'm going to want to have a file watcher. And look at that, now we have green text. So it does work. That'll work. Who would have thought? Been loving your videos lately. Got me inspired to continue my own engine. That sounds awesome. I was wondering if we were to restart, would you use Zig as a base language instead of C++? Probably yeah. Probably yeah. So I would still most likely have use a bunch of C++ libraries. You can see here that the way this is set up currently is that we have an exe file which is written in, or an exe project which is written in C++, and then we have a core engine library which is also written in C++. What I would probably do today if I started with Zig is that the exe project would be C++. This guy would, the exe project would be Zig. This guy, the core engine, would probably also be Zig, but I would still use a whole lot of C++ libraries, things like physx, for example, which is, you know, this engine is, or this game, I should say, is very heavily kind of dependent on there being a physx that we can use. And just put that back to where it was. Yeah, because there are just like so many useful C++ libraries out there that not being able to use them would be a bit of a downer to me, at least personally. And using a C++ library from Zig is not super simple if the library doesn't have a C interface. So then it's sort of like a question of like, okay, so do you make that C interface yourself somehow, or what do you do? But yeah, I think I would sort of like, you know, bring Zig into these two projects and kind of like push away the C++-ness of it all. Dynamic UI layout is super difficult. It is, yeah, absolutely. Especially when you get to internationalization and localization and that sort of thing, right? Then it just becomes super difficult. You are betting hard on Zig. Well, yeah, I mean the game is written in Zig. That's kind of the language I'm choosing for this project. So far, it has worked out pretty well. I've also been thinking about that. I already have been working. Oh, sorry. I've also been thinking about that. I already have been working about restarting my engine in Sigma. That's a bit too difficult. Yeah, it's an interesting question. I'm gonna go out on a limb here and say that if you are sort of in the phase where you are, how should I put this? If you're in the phase where you are free to restart your engines, it kind of sounds like you don't have like a whole lot of code already written. Maybe you have an engine that you used for some amount of time, and you kind of have an idea of how you want that engine to work. But you're still sort of in a place where you can restart engines and all of that. I'm like way past that point. Like I have years and years put into this thing, so I'm gonna have to live with it a little bit. But I would maybe try giving Odin a shot. I'm not a huge fan of the Odin language. I'm just gonna go right out and say that it's not a bad thing. It's not a bad language. It's actually a pretty good language, but it's not necessarily. I don't like it as much as I like Sig or C3 on the language level. But I know certain people do, so this might be right up your alley. And what Odin has going for it is that they vendor a whole bunch of Gamedev things directly into their, so almost like standard library. It's not quite standard library, but so it's sort of like a collection of ready-made bindings and all of that. That's super awesome, I think. So, this might be something to try if you kind of feel like Sig doesn't really give you enough, batteries included, if that makes sense. I like the Sig language more than I like Odin, but I do agree that like it's kind of rough to get going with Sig, because the language like lives quite a lot, and so bindings tend to get outdated and kind of deteriorate pretty fast, if that makes sense. And so I think Odin might give you a nicer set of libraries included that just kind of work right out of the box. So yeah, maybe give this a go and see how you like it. That might be something to try. Odin sounds nice, but I would love to use Jai if it ever releases. Yeah, no one knows when that will happen. I think they're busy shipping that game now that they're building. I don't remember the name of it. It was something pretty long. There's also C3, which I think is a nicer language than Odin. And if you want to see me mess around with Odin and C3, I did so like a couple streams back. One where I look at Odin and then a little bit of C3, and then one which is like all C3. This is a very nice language. The tooling though is not quite there. Not for me at least. I need more intelligence and hand holding these days. But yeah, they each have their strengths and their weaknesses, I should say. Rightio. So we've done a little bit of hot reloading here, and we can see what happens here when we actually hot reload is that okay, we're loading some like Windows DLLs here. Then we're loading this means game hot reloading pong, and then ping, and then pong. So each time you make a hot reload, you can see that ping ponging down there, back and forth. And that is of course because we can't really load the library that we're building, because that would block the DLL, so that we couldn't actually write to that. And so what I do instead, and this is something that we did in the last stream, is this thing where let's see, where do I actually call that? Right, so it's here. Load Zig app library. And we pass it whether or not we are making this a hot reloadable library or not. And if we are, or first of all, if we don't do it, we come here to this else case, where we just quite simply load the library. But if we do hot reload, we make the Zig app library hot reloadable, which basically just means figure out a new name for it, which we do here or here, depending on whether we are in debug or not. And yeah, then we append the DLL extension and blah blah blah, and then we copy the file for it to the new destination, and then we return the destination. So what that actually means in practice is that we're going to build and release, and then we find the library called means game, which is here, and this is the thing that we are actually building. When I hit Ctrl-Shift-B in Visual Studio Code, we are producing this file here, and then we copy it to ping and pong, and each time we reload it, it sort of copies it to the other one. And that means that this main DLL, means game.dll, is left untouched. It's not loaded, which means that we can keep building it in the background. It doesn't get blocked by the game. So that's the idea here, and because of that, we get these alternating ping pong, ping pong, ping pong. It could be, it could be whatever. It could be 0 and 1 or whatever, but ping pong is kind of like a term that at least tells me kind of quickly that, okay, we're sort of alternating between those two. So that was the idea. Just by the way, if you're wondering about something, because this follow-up stream was something that was kind of requested last time, that hey, got kind of didn't really finish what we started, so a follow-up stream would be appreciated. If you have any questions, just feel free to ask away. I'm probably gonna do a little bit of work here because this thing is not really finished. It is finished enough that we can go into the game and we can hot reload things. We can even go into like an actual game. We don't need to stay in the menus, and we can hot reload things. But kind of depending on what you do in the game, there are things that might sort of break. Does hot reloading get shipped with the game, or is that stripped out when released? It gets stripped out, yeah. I mean, there's not really any point in having it shipped with the game. Let's see. Yeah, so it's here. No, it's not there. It's the thing that's called this. Makes Zig app library hot reloadable. So yeah, it's here basically. You can see here, basis config final. So when we're making the final build, that part gets stripped out. That's why this kind of strange order here. We have like a curly brace, then we have else, then we have end if. So basically, essentially what happens in the final build is that we strip all of that away, and then we just have a pair of curly braces there, and that else is removed as well. So at that point, this hot reload parameter doesn't do anything. It just looks like that. Like I don't really have any problem with shipping it, but like who would benefit from that? I don't think anyone would. You can already script the game and program for the game by making mods, which can be loaded as either like DLLs or WebAssembly modules. So I don't think you really need to make like hot reloadability a thing. Well, you could hot reload mods if you wanted to. Yeah, that could be a thing. That could be a thing, at least in DLL form. We'll see. Maybe I'll make that a possibility at some point, but not right now. It's only for the app library. So, what happens when we press that hot reload button then up there in the menu? Let's go have a look. So, perform hot reload Zig app library. Right? We have this boolean here. Zig app library hot reloading pending. That's a boolean. And it gets set to true up here. No, actually it's not up here. It's somewhere here. It's here. We assert that we have the hot reload library enabled, and then we set it to true. And then this boolean is read during this update phase. This is code that we wrote in the last stream. So because we have a client and a server in sort of a networked fashion, running potentially on two different threads. This comment says here that if that is the case, that we need to sync both of those threads together under this thing called a thread gate. So Zig app library hot reload thread gate, which has a lock and an unlock function. Basically that means that when we arrive here, if we are in threaded mode, between this lock and this unlock function here, we can poke at the library. Otherwise, what might happen is that the server thread is trying to run some code, while the main thread is trying to hot reload the library, and we get a crash. And we actually did get a crash in the last stream. So, inside of this perform hot reload Zig app library thing, this is where the entire hot reloading of the library takes place. Some of this stuff we wrote last stream, some of it is new, so let's just quickly go through this. So we copy that library to the new path, which is either the ping or the pong one, and then we load that, right? Get a new dynamic library out of that. And this thing just like goes through and calls essentially load by path, and then it calls load library. It's right there. That's the OS call to load it, or DL open if we are on like a non-Windows platform, right? So that's that. We load the new library. We get the old library, which is still loaded, and we do hot reload native phase 1 on the new library. What does that do? Well, it does sort of a handshake between the game engine and the Zig code. Hook up exported functions. We looked at this last time. This is basically like if we go into the Zig code here and have a look. You have just a whole bunch of exported functions in the Zig code that we need to hook up. So we can go into, for example, library API for let's go for basis. Because the export function, we have just a whole bunch of these guys. We need to get function pointers to all of these things so that the game engine can still communicate with the game, and it does so through these export functions. And then it checks some flags here. If we did some really crazy changes between the new and the old library, such as like we removed entire like middleware and things like that, then these flags are not going to match, and you're going to get an assert failure here that hey, you're trying to do something completely crazy, like you didn't use the particle engine before, but now you are using it, and you expect the memory to work with this new thing. Like, what are you thinking, basically? And then we bind the core types. And we bind the core types, and then we bind the sort of normal game engine types. And what does that mean? Well, it just basically means calling a whole bunch of functions to hook up function pointers. So here's bind app, bind mod controller. I'm not going to go through all of this because I showed it off in the previous stream quite a lot, but if you have any questions, like before, just ask. Bind client, bind server, and it does like a whole bunch of things here. It does like mesh bindings and ImGUI bindings and network and scene node and physics and vehicle controller, all kinds of things. So that's the hot reload native phase 1. This is done now on the new library. So we're essentially here. And then we do the same thing for the libraries. So the libraries in this case would be like the sound library, the particle system library, the mission scripting library. If we go in here and have a look, oh, that's actually a virtual function, so we need to look for the proper one. Yeah, there's a virtual void. So C++ selects the correct one for us, and it goes here, and it checks based on those flags, which again need to be the same before. So Goofy is the UI library, Timbre is the sound library, Nemo is the mission scripting, Merlin is the particle system, and then Trampoline just has some utilities. Needs to basically bind all of those types, all of the same types that we had before, and they better match, otherwise we're gonna get an assert error. Then we do hot reload native phase 2. And this is now where things get really, really interesting. At least I thought this was kind of interesting. So the way I do hot reloading here is you need to transfer the state from the old to the new library somehow, right? Like we looked at this machinery DLL hot reloading in theory and practice from the old Our Machinery blog some time ago, and here was something that sort of like a list of things that you need to kind of take into consideration if you want to do this sort of hot reloading thingy. I'll just post this in the chat if you guys want to have a look at it yourself. and this state transfer is a pretty big one. If you haven't set that up before, because you can of course reload the game as you are actually playing the game. So if you go into, where should we go? Let's go into plane and car. This is like the very, very simplest of levels. It has just a plane. We can put a car here. We can make that our car. And now as we are driving around here, we can do a hot reload. Bloops. You can see almost nothing happened. We do get a hot reload. Whoa. Hot reload output here in the debug console that we reloaded. We did the reload pong thing, and if we do it again, we get the ping one, and then the pong one, and so on. And that's all fine, but you can see that like the car is still rolling around. You still have the particle systems particling. Everything is as it was before the hot reload. And so for that to be the case, we need to transfer the entire memory of the old DLL to the new DLL. So how do we do that? And indeed, that has been one of the trickier things for me to do here. Mainly because I just hadn't written my gameplay code in a way that would have made that easy, basically. You can even pause this, and I bet it probably works with a paused game as well. There we go. I'm gonna hot reload it a couple of times and then unpause it. And so how do we do that state transfer? Well, we do it right here. We allocate a few megabytes of temp storage for transferring the global data from the old library to the new one. In theory, we don't need 2 megabytes. We need basically like maybe 16 bytes or something like that, because we're only really transferring a few pointers across. And I will show you how that works in the Zig code in a little bit. But yeah, the engine code here is written with the sense that you can stuff a few things in there that aren't pointers, that actually take up some memory. So I just pulled 2 megabytes out of a hat and put it here. So we have that much temporary storage. And out of that storage we create a buffer, which has the pointer and it has the size, and that's just the position. So it's like at the very beginning. I think that's the position at least, or is it the? Oh, that's the capacity and length. Okay. All right, that's actually a bug. That's actually a bug. That should probably be. The length is the last one. Yeah, it's set to 0. I don't actually know. It's fine. It's fine. Anyway, and then we hook up a function called before hot reload on the old library. So the one that we currently are running the game with. What does that look like? Well, let's go find it. It's found here. Before hot reload, you can see that it gets that buffer sent to it or given to it as the parameter. Out of that, we create a data stream, a write stream. And then we can write to those 2 megabytes, whatever we want. Here we basically just store the state, which means that we push a couple of pointers to that stream. We push them as integers because C++ doesn't really know what a zig is or what a zig pointer is. So we convert them to integers and then we push those integers. And they're just U sizes. Push them to the stream. And then we do the same thing with the other libraries. So this would be the game's global state. This would be the main engine's global state. There's the vehicle helper global state. That's just a library. And then Goofy, the UI thing, also has some global state. The other ones didn't actually have any global state that needed to be transferred across. But yeah, this is where it would actually do that. And so we call that, and then we get some stuff put into this buffer here. And then we run after hot reload on the new library, right? After hot reload is done here, found here immediately beneath this thing. So obviously, like, both libraries need to have this. If again we do a hot reload with the new library, then that libraries before hot reload will get fired, and then the next libraries after hot reload will get fired, and all of that. And again we get the new buffer passed to it. And here we quite simply do the opposite. We get some integers out of them, and we stick them into the pointer form that they originally were stored in, right? So we actually transfer very little memory here, and that kind of hinges on the memory actually surviving this entire operation, right? That memory needs to be somewhere that doesn't die when the old DLL gets freed, and we'll get to that in a little bit. I'm gonna have a little bit of coffee. So, what happens then? Well, then we just switch out the libraries. So here we have the native dynamic library, we switch it out for the new one, for the new library. And then we delete the old C API and assign the new C API to be the API, right? This thing is just a struct which has a bunch of function pointers, like this. These are all of those exported function pointers or exported functions that we looked at. And we actually have quite a few. 180 or so, or maybe 150 per library. And of course we need to get rid of the old function pointers and instead point to the new ones. So that's why we just assign that here. Over there, and then we delete that temp buffer because we no longer need it. We've done the state transfer. And after that we can jump back. So here is hot reload native phase 2. That's this function here that we just looked at. After that we can unload the old library and we set the hot reload pending to false. And that's everything that happens on the C++ side. So it's actually fairly simple when you look at it from like a bird's eye view like this. It's like 10 lines of code here basically, and we have some printfs and things like that. But of course more stuff happen inside of those functions, but it's actually very simple. So we load the new library, we're on this phase 1, which hooks up all of those function pointers. Then we do the state transfer. Actually no, we don't. We bind some stuff. We do the state transfer and then we unload the old library, and that's it. So actually very simple. We almost had all of this in the last stream on the C++ side. It was actually kind of complete. Just a few small tweaks that needed to be added here. For example, this state transfer thingy was the big one. So that's very simple. The rest of the stuff will actually be in the Zig code, and like essentially making it stay alive, even though the DLL is being unloaded, and that has been like where the majority of the time has gone into making that happen. So I mentioned that we only assign a few pointers, and then magically all of the global data is right there. Like how does that work? Well, previously I had a bunch of global data just sprinkled in various files around the code base. So for example, if we go to library API, probably not that one. Let's see, is it maybe just api.zig? Yeah. Things like this. And so here's an example of something that is still actually global data. This is for the WASM stuff, and WASM, at least right now, won't have any hot reloading support, just for the DLL stuff. But anyway, this is an example of like, it's not really global data in the sense that every Zig file, so this is an api.zig, every Zig file you can instantiate multiple times. So it's not really global data, but like for all intents and purposes in this code base, this temp memory ring buffer thingy here is global data. And I had just a bunch of this stuff previously. You can typically find it with this like G, smaller G, and then the name that just stands for global. And yeah, we don't have a whole lot of, we just have some like game master things like Gauge Arc Center, things that start with a G. But yeah, we had a few of those cases previously. Don't really have that anymore, because if you have this sort of thing, when you unload the DLL, that memory also dies with the DLL, and so you can't just assign the pointers across. You have to actually mem copy the whole thing around, and that's tricky because some things aren't just trivially mem copyable. For example, pointers tend to need some kind of fix-up afterwards. And it's also just like a whole lot of work to make everything mem copyable. So I figured I'm not gonna do that. Instead, I'm gonna put all of my global data on the heap. And if I put it on the heap, and I manage the heap outside of the DLL, then the memory will survive, even though the DLL is unloaded, right? And so how does that work? Well, first of all, we have our own allocator in Zig. Which we can find here. We have a few different versions. You can use the standard debug allocator from the Zig standard library if you want to, but it's just hard-codedly set to false here. So instead, this heap allocator through this if will go to this else clause, which is the basis memory heap allocator. And then also, if you're building as WASM, your only real option is to use the std heap WASM allocator. But if we're not building it as WASM, then this becomes false. So we select heap allocator, and then this becomes false. So we select the heap allocator here. That's why we have this basis memory heap allocator, which gets selected. And this guy, you see the alloc thing here, this actually calls into the C++ side to get memory from the allocator. So that kind of stands to reason that, like, even though we get rid of the DLL, the memory that have been allocated here on the core engine side is still alive. And that's how we can, just by assigning a couple of pointers, we can essentially move all of the global data memory to the new one, right? So now the question is like, okay, how do we actually store the global data on the heap? That sounds kind of tricky, and yeah, it is a little. It's not tricky if you do it from the beginning, but it's a little tricky if you don't do it from the beginning. So previously, let's just go into, say like the main menu here. Main menu UI view model. Looks like this. We have a bunch of of free functions here. These are not part of any like explicit struct or anything. It's part of the struct that is implicit here from this Zig file. But they're essentially just free functions. Deactivate void. It doesn't take any parameters, nothing. You can see that all of these now get a global data pointer for the global data that this module has. Not necessarily exactly all of them, but most of them do. Because they're going to want to actually mess with the global data. This is one of the really big changes I had to make with this hot reloading. If you want global data in a module in Zig, and you want that to be hot reloadable, you have to store it in a global data struct. So where is that global data struct? Well, it's found here towards the top of every file. Global data is right here. Here's all of the stuff that was typically previously like looked something like this, and then it had like the var keyword there before each line, right? Looked something like that. But since we can't have this anymore because this memory will die if we unload the DLL, we have to put it in a struct so we can actually sort of like keep it together like this. And then we have to store that struct somewhere. So where's that then? Well, it comes from this thing here. Get G is like get an instance to this global data, and it's found here under this horrible looking path. There is a library global data, which is sort of a collection of all the global data for the library. And this thing has just a whole bunch of those guys. You can see AI driving profile, global data, options, global data, music player, global data, impact FX, blah 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 blah. So since this is the main menu UI view model, it will be found under the UI manager's global data, which in turn has a bunch of other, here we go, menu UI view model, and then this one has the main menu. And if we click this guy, we go back to where we just were, because this is where we found it. So this is essentially sort of like a path. I think of this almost like a breadcrumb trail, right? And yeah, this was a big change. This took like maybe a couple of days just to convert the global data of the entire code base to be placed on the heap, right? If we search for this line, you see we have 26 of these modules all in all, apparently. I think there should be more actually. And these are all in means. All right, I think means is probably the only one that actually uses it. If we look for this one, we should probably find more. Yeah, now we can see 49. Yeah, we can see some in basis in the core engine. Here's some UI stuff as well. Yes, indeed. Right, so that's that. That is how I transfer over the global data now. And now that this is done, it's actually kind of simple to just like keep working like this. It's not a big problem, rather than just putting stuff directly on the file level. If you see a struct like this called global data, you know that, okay, I can just store things here, and then I can get that through this get G, which is force inlined. And so that's kind of neat. So when you know all of that, it kind of makes sense that, okay, yeah. Okay, we have a small temp buffer here. We read those pointers from the old DLL, and then we write them to the new DLL. And then all of a sudden, something like get G will point to the same memory on the new DLL. and everything would just work. So that's why we can just do a hot reload here and boom, nothing happens. None of the particles go away. The transform of everything is exactly where it was. Even though we're switching out all of the code underneath the objects here. It's pretty neat. You can't actually even really see that anything is happening. There's not really any frame hiccups or anything like that, which I find kind of interesting. There's maybe a very, very slight little thing if you kind of know that it's happening. We've been reloading this now for like 15 times or so. So that's that. That was the global memory. That was a big thing. It is pretty much done. There might be one or two things that kind of need a little bit of thinking through still there, but it's mostly done. There's one interesting thing here though. If we go and have a look here at the here after hot reload, and we look at, I think it's this guy, isn't it? Oh, it's here. It's restore state. So as you may or may not know, Zig wants allocators for everything, explicit allocators, and these days he also wants I/O for things that actually do I/O. So the allocator in Zig is an interface. It's a pointer to something, and then it has a v table, right? That v table contains function pointers to allocating, resizing, remapping, and freeing, and data. And the problem here is that if you pass one of these guys within the context of the old DLL to something, and it starts allocating from it, it all works fine. This allocating function here, or this function pointer, it points to a function. In this case, it will be pointing to the heap allocator's alloc function, which we just looked at. It is here in memory. It will be pointing to this guy, alloc. And why? Because we're assigning it here to the alloc v table, right? So this all works fine. And then this calls down into the C++ side, core heap alloc. This core heap alloc function never actually moves anywhere because it is on the C++ side, so it's completely fine to just keep calling that even after the thing has reloaded. This function, though, is not gonna stay around because this function is part of the DLL. And so if you try to just use the same allocator through that interface from the new DLL, you get a crash because this function is no longer there. It has moved, and it is almost guaranteed. Well, it is guaranteed to be moved. It can't, even in theory, it can't sit at the same address because we are loading both of those DLLs at the same time for a little bit before we get rid of the old one, right? So that's a problem. This guy will always move around every time you load a new DLL. So how do we handle that? Well, I handle that by if we go here and we go to the library global data for the game, and we can see here that I've kind of nailed the allocator v table in place here by actually putting the allocator v table itself on in the global data. So rather than just returning an stdmem alloc or stdmem allocator, as you are sort of, as you typically do when you're writing Zig code, I only use the allocator which is found here. Global allocator and IO interface. That's the IO interface. That's a global allocator. And this global allocator, every time we do a hot reload, I need to patch this guy up so that it points to this guy, and then I need to patch this thing up so that it points to the new function pointers that are found in the new DLL that we load. And that way, if people use this allocator thing here, it will just work. And so how does that work? Well, when we create the global data, we create an allocator just normally like this. No, sorry, we create the library global data there. Sorry, we create the library global data, the entire global data sort of object. But then we start actually like poking at things, because we've been assigned an allocator, and we copy by value, so no pointers here. We copy by value the entire v table over to this allocator _allocator v table, which lives here in the library global data, like this. So it sits in place, right? And because it is found in the library global data, it will sit in place even though the DLL is unloaded and reloaded. And then for the actual allocator that you're supposed to use, so this dot allocator, no underscores or anything like this guy, we fix it up so that the pointer points to whatever we got, but the v table points to this global thingy here. This is very important to do. If you forget to do this, then the v table will point to something that's no longer there, essentially. And then every time we do a hot reload, we can see here, restore state, we need to patch the allocator pointer with whatever we got in, and we need to patch the allocator v table again by value into the allocator v table that we store in the global data. And that way the allocator v table in the global data will always point to the correct functions. Because what we get in here, these are the new functions. So the new alloc, and essentially in this case here in our own allocator, this guy, this alloc function and this free function from the new DLL are patched into it's here, patched here into this _allocator v table. That's quite a mouthful, this whole explanation, and it took some time for me to figure out why my allocations were failing, even after because it kind of makes sense that, okay, you have a heap that you're managing yourself on the C++ side. You're not deleting that heap is still there, and you're patching up all the pointers. Why does allocating from that heap no longer work? And of course the reason is that there is like an additional indirection. When you allocate something through a standard SIG allocator, you're going through a function pointer here on the SIG side. You're not just going directly to the C++ side, which still lives. You're going through a function pointer first on the on the SIG side, and that function pointer was dying, so it pointed to garbage rather than to this thing here. I hope I'm explaining this in a way that kind of makes sense. If you have any questions, feel free to ask me. So yeah, this takes some time to figure out. Once I figured that out, it just worked beautifully. Because, again, this core heap alloc function still sits in the same place on the C++ side. So you can allocate from that, no biggie. Okay. So that was the global data and the allocation taken care of. Now we come to the next problematic thing, and something that was kind of brought up in the previous stream, and I kind of brushed it off a little bit, like, yeah, it's not really a big issue. Well, it turned out to be trickier than I thought, and that's the concept of function pointers. It's basically exactly the same problem we have here with the allocator, where we have a function pointer that looks like this. This is how function pointer is denoted in Zig. And function pointers that you yourself make in the in the game code, and how those function pointers are pointing to crap after you reload the DLL. And this is something that I kind of knew was going to be most likely an issue, but I didn't really understand how large of an issue it was going to be. And that's something that's kind of still a little bit under works. You know, we can do things here in the game, and we can reload the game, and it kind of works. But I can pretty easily actually break this game. So let's show an example here. Let's put a gripper truck here down. We can go into the gripper truck like this. Everything works. We go to the gripper arm. We can move it up and down. Now watch what happens if I hot reload. You can see that, okay, yeah, everything is still working. Uh-oh, something crashed. Oh no, where are we? And here we can see that, okay, we were trying to set a steering value, propagated value here from the gripper truck arm component. So I was trying to move this yellow arm up and down after the hot reload. I was trying to set the steering values. It goes forward. Yeah, that's fine. That's fine. We're setting it in CPP, and that triggers some kind of fallback or callback to happen. And here we go. Okay, so we are in the set function now. This arrow is kind of confusingly over here, but we're basically running this value changed callback. All right, so then we got the value changed update in PV in Zig. Okay, so now we're back on the Zig side. Set propagated, and here we have the Zig callback. And then we try to execute a delegate, a void delegate 3, and we get some crap data. And so, what basically happens here is that we have a value changed callback somewhere in the gripper truck arm component. Let's go have a look at what that actually looks like. Then we can actually fix this. I fixed a bunch of these already, and I'm kind of making a list. So gripper truck arm component, and it's the steering values, propagated value. Let's look through the file and see where we have that. Okay, so it's a propagated value for vec2, and here's the handle. And we can see, okay, the x coordinate contains the arm rotation amount, and the y, the finger open amount. Makes sense. So we go forward. Okay, here we're we're initializing it, and here we're setting it, and then spaghetti-o, we're setting a value changed callback, which is a method, and it's set on this on steering values updated thing. Now there's the root of the problem here. Then we're deinitializing it, and we're using it, and blah blah blah. It's not really important. This thing is the problem. In the create method for this component, so this runs when we create the gripper truck, we're telling the system that when this steering value, propagated value, updates, we want this on steering values updated function to fire. This thing here. Now what we did there with the gripper truck is we created it, and then we did a hot reload, and then I tried to move the arm. So this creation thing here happens before the hot reload, which means that this delegate here, which is a function pointer, glorified function pointer, it has moved. In the new DLL, the function doesn't exist at the place where we expect it to exist. And so we're gonna have to fix this. We also have a gripped object name hash propagated value, which is a propagated value of a string hash, which also does something similar. So these two things quite simply have to be rerun with the new DLL to patch up the delegate with the proper values. Otherwise you're going to get crashes like this. And this, of course, is something that I do all over the code base. Like, almost everything has delegates like this. Some of them are propagated values, but some of them are just like completely different kinds of callbacks. Like you start something and then you get a completion callback when it finishes. All of those have to be patched up when you do a hot reload. So that's a fun thing. Another thing which breaks because of the same reason essentially, but it's used in a very different kind of way, is interfaces. So I use interfaces in a few places, not like in a whole lot of places, but in a few places. I use interfaces, and I came up with a pretty nice way to actually fix the issues that come with those. But let's have a look first at how that actually works. So we have something called a timeline. So a timeline is essentially like if you have a sequence in Unreal or something like that. You have essentially like a timeline onto which you can sprinkle events, and then those events can do different things. And so, for example, when we run the game and we go here into this menu, you can see this slight little animation here. The logo is sort of fading in, and then these buttons appear, like one after another, like this. Let's play it again. Like this. That's a timeline that drives all of that stuff. And all of those events that you can sprinkle onto the timeline, they have callbacks. They don't have callbacks. They have interfaces. They implement an interface. Some of them have callbacks, yeah, but that's actually not what I meant. So we have the timeline event interface. And because you can sort of think of it as a timeline, you know, if we have let's bring Milton back here. If you have the time, you know, progressing linearly like this, you can have these kind of like tracks almost. And then you have some events. So you have an event that like sits here, and you have another event that sits here. And then maybe you have one that kind of like overlaps with that a little bit. Hey Nikita, welcome back. And thank you. I plan to have a good stream. Right, so then you can sort of evaluate the time at some particular place, like there, or like maybe there, like this. And time progresses left to right like this, right? So when you are at this point, you would trigger the enter event or method for this particular. Well, this is called an event. It would trigger the enter action for that event, and then when you arrive here, trigger the exit one, and you can have several of them active at the same time, right? That makes sense. So if you know that it kind of looks like that, you kind of understand that, okay, they can have an enter function or method. They're not really called methods in Zig, but let's call them methods anyway. Member function, whatever. Enter, exit, tick, and then get start time, get duration, or is instantaneous if they're like essentially like an event that is just a single frame, like, you know, fire a script callback when that happens, something like that. And so this is an interface. Zig doesn't really have interfaces, not on a language level, but you can make them yourself like this. You just make a virtual table yourself. So struct that has a bunch of function pointers, and then you do whatever you want with those function pointers, right? How I use that is I have a function called make. You pass the actual type that you want to actually have implement this interface. You give it a pointer to one of those things. And then this type name hash is a new thing that I will explain in a bit, because this didn't used to be here before, but now it is. And then you set up the vtable like this. And then, you know, typically it goes through. If you're firing the exit function, it kind of figures out, okay, does the thing have an exit function? Oh yeah, it does. Okay. We're casting to the correct type and we're calling exit. Blah, blah, blah. That sort of thing. Well, as you can imagine, based on what I just told you about function pointers, all of these guys are going to point to functions that live in the old DLL's memory, right? So everything will break once again. And it's kind of nasty, actually, to handle these things, because if you're looking at the timeline here, the timeline is the container for you know, one of these guys. The reason we use an interface here is that we can quite simply have an event data that has a start time, an end time, a state, and an interface. Here's the interface. And then we can just have a list of those guys. An array list of event datas. So that means that like this guy can be of a certain type, and this guy can be of another type. Maybe those guys are the same. And then this instantaneous one here can be of yet another type. But the timeline doesn't need to know what those types are, because it only knows that, okay, they have this interface, and it can call enter when we entered it, exit when we exited, tick when we're inside of it, and we can get its time and its duration and blah, blah, blah. We don't need to know what the type of that thing is, right? Now the problem here is that if we want to fix up those pointers later on, we kind of need to know the type of it. We kind of need to know what it was originally created as, so that we can hook it up to the correct functions, right? So if we have a screen fade screen color event, it looks like this. It has an enter function, it has an exit function, it has a tick function. We need the address of these guys for this particular function to be able to you know, actually work, right? You can't just go like, okay, yeah, rehook it to whatever you had before, because it doesn't know what that is. So that's a problem. Okay. Then you can, of course, you know, manually go in, and if you know what those things were, you can go manually go in and rehook it. But we don't necessarily know what they are, because they might be coming from a script, for example. They might be coming from data. There's no place here in the code that knows what those types are. And so what I did here is add that information to the interface itself. And because you're making these interfaces here by hand, you can do things like add a type name hash here, right? If I was using C++ for this thing, C++ has language level support for interfaces, and it also does vtables, virtual tables under the hood, but you don't really get to poke at them. At least, like, you're not supposed to. And there can be some like compiler specific differences and platform specific differences and things like that. You can quite easily actually break things if you go and poke at the virtual table here. But since SIG doesn't have it, you kind of have to build them by hand. And because you build them by hand, you can just poke at them by hand and nothing will break. You can of course do all of this in C++ as well, but like, let's face it, none of us would. we would just use, you know, purely virtual types, aka interfaces in Zig. And then we would be screwed when it came to something like this. Because what I did here is I added this type name hash. The type name hash is given here when we make this type. So you can kind of think about the type name hash as a type ID. And SIG has a concept of a type ID. The problem is that the type ID is not guaranteed to be stable, especially not if you make changes to the code. Same type can have a different type ID next time you build the thing. And we don't know these anymore at runtime, these types here. So how do we actually generate the type ID for these? Well, the way I solve this is by constructing a list of all of the possible types that you might give in here to this type. So here we are looking at the timeline events. And if we go have a look at let's go look at the game code, timeline events. Here we have all of the timeline event types that the game specifies. So sound event, camera animation, full screen SVG animation, script, start mission, abort mission, end game, play managed sound, and cleanup managed sounds. Those are all of the timeline events that exist in the code that you can theoretically add. So we have this list. Supported types is, well, this list. Plus, it's also the game helper library's timeline events. Test event. Well, that's a test event when I develop the system. There's a callback event, callback with data event, no op event, set screen color event, and fade screen color event. We looked at that one. So we have a list here as well. Together, these two lists make up the entire list of supported types that we might ever give to the timeline component, right? When we know that, we can create something called a type with name hash. This is a very simple little struct, looks like this. This is where Zig's comp time coding magic comes into play. This is super, super nice. So this is a function, you give it a type, and it returns another type. So it returns a struct that has the type that you gave in, and it also has a name hash. The name hash is done right here. It's an Adler32 hash, so it's not a particularly good hash, but this is nice because this can be done at compile time. So at compile time, you hash the type name, and you get out a struct that has the type and the name hash. And these are going to be the same between two different loads of the DLL. You're not supposed to like add and remove things from these lists in between hot reloading and DLL, but if you do that, then you're sort of like playing with fire anyway, and your game is probably gonna crash. But this is a way that I can get a reasonably good unique ID for each and every type that might be in those interfaces, right? Then I have a comp time check here that if by some really unfortunate chance I happen to get hash collisions with these types, it just doesn't even compile. So if I accidentally have like this type 2 times here and I try to build this, we're gonna get a compile error. Timeline events, blah blah blah. It's a long type name here. Play managed sound event has duplicate type event with another event type. Well, it's actually the same one because I just added it there. But anyway, you get a compile time error which tells you, oh, that's gonna be an issue. Okay, so how does this now solve the issue with those outdated function pointers? Well, I'm glad you asked. Let's go to the timeline type. Timeline is down here. Boop. So timeline again. This is sort of like an instance of one of these sequencer thingies. You can create these from script, or you can create them directly in code. And like I said, the animation there in the main menu is like one instance of these guys. So this thing now has something that like a whole lot of other things also have. They have a before hot reload and after hot reload method. here's a comment about something that I actually haven't done yet, and I probably need to do at some point, but I haven't done that yet. So this thing is actually not used anymore, but it's sort of like a convention now with this, that if you have before hot reload, you will have after hot reload as well. After hot reload is typically actually the more important one, because that is where you do all kinds of fix-up things. So here we do fix-up action vtables. And again, we need to pass all of those supported types in here. So that would be, you know, if you're building traction point, that would be all of the traction point supported types, which is found up here in the, here we go, timeline event types. If we find this, we can actually probably find the place where it is. Oh no, it's not that. It's supported types. There we go. Yeah, supported types is the entire set of supported thingies. So the main menu UI view model, for example, you can see here, reveal animation dot timeline after hot reload, and we give it the entire list of supported types that we might ever find in that timeline. Reveal animation is exactly that animation that I looked at. So, what do we do? Well, we call fix-up action vtables. What does that do? That runs through all of the events, the items, and this thing is the list that we looked at previously. ZLS just doesn't want to show it to us, but it's this list, events, that has this event data, which again doesn't know the type, the underlying type of the thing. It just has the interface. But now that interface has that type name hash. And with that, we can do an inline for. This is a compile time construct in Zig, which just essentially like flattens this for loop here into just like all of the different elements that we have here. And we check, is the interface type name hash the same as the name hash for the type that we are currently looking at, right? So again, type info, we're looking at this guy here, this struct, which has a type and it has a name hash, and both are known at compile time. So basically we're looking at, okay, is the name hash the same as the one in the interface? If that is the thing, that we do the setup for the vtable again with the type. And so this is a way to sort of like piggyback on the interface and find, oh, okay, what was the thing that might have been, what was the thing that might have been originally used to set up this interface? And then when it finds it, it knows, okay, it's that type, and then it plugs that back into the vtable there. I'm gonna make a note for myself here. Fix the timeline. What it's called something like scripted timeline component TL vtable. Because I just realized when I was talking about all of this stuff that we do it here for the pause menu logic, and we do it for the main menu, but we don't do it for the scripted one yet. So it just needs to happen, right? Rightio, and we need to do this for all of the interfaces that we have. We luckily don't use interfaces all that much in Zig, because like as I said, they're not natively supported, so you have to do a little bit of work to make them to make them happen. And because of that, I typically don't use a whole lot of them, but every now and then it's super nice. Cases like this, it's very, very nice, because then the playback system of this doesn't really know what each and every one of these guys are. It just knows, oh, okay, they all implement the same interface. We can enter them, we can exit them, and we can tick them, and we can get some information about them, and that's about it. Right. So that was vtables. And then finally we have the delegates. And the delegates are, that's like this thing. Delegates and callbacks, I should say. So delegates and callbacks. a callback can be a delegate, like here, set value changed callback for this propagated value handle. I was thinking we would fix this next as a live thing here on stream. Make sure that we can actually hot reload the entire gripper truck and all of its stuff. So yeah, this is a callback that uses a delegate, but a callback can be just like a raw C function pointer into the C++ side, whatever. They all need to be fixed up. Actually, no, those don't need to be fixed up. No. Well, they kind of, yeah. They don't need to be fixed up, but typically it's the other way around. You're passing a raw C calling convention pointer to a sig function, and you pass that to the C++ side, and that does need to be fixed up. Yeah. Okay. So this is basically what I've been doing since Monday. I'm gonna make this a little smaller. Do let me know if you want me to enlarge the code. We are 1.5 hours into the stream, and I'm basically done with like explaining why this has taken 5 days to happen. Now I figured I would go perhaps get a glass of water, and I will stream for maybe an hour, maybe an hour and a half more, and we will fix up some of these issues here. And basically just keep working on this thing. So I have an Excel spreadsheet here. It's a beautiful Excel spreadsheet where I'm tracking some of these things. Not all of this stuff need to actually be fixed. But like some of these things were just like absolutely crazy, like the HUD and the menus. They're basically all done now. Yeah, we have some dialogue callbacks. The RPC things needed to be done. Here's some more UI and menu things. We have a whole bunch of components. The components that actually have this set value changed callback thing is they're tracked here separately in a list. So I think this is like my next thing to fix here. But yeah, these are all of the Zig files in the entire game. So we have a lot of them here. Yeah, here we have the timeline events, for example. Some of these actually need to probably have a little bit of a looking at. That was an exciting lecture to hear. Glad to hear it. Yeah, do let me know if anything that I was talking about here is stupid, or if I'm doing something like in an unnecessarily complex way. This is all very new to me. I've never done this, and so I wouldn't be surprised if there was an easier way to do some of these things. But yeah, I think the main problem for me with this is that I'm using so many callbacks everywhere, and they need to be handled, and they kind of just like need to be handled separately, or like, you know, by hand. You can't really make a system. You can't really make a system that does it automatically. Well, you kind of can. You know, Live++ exists after all. But you know, like in normal end user land code, I don't really see how you could do like a re-hooking up of function pointers automatically, because you kind of need to give the function itself for the compiler to get the address of it. So it's a little bit of work, quite simply. It's the annoying truth of it all. So if I didn't use a whole lot of function pointers in this code base, I would essentially be done right now, I think. But yeah, it is what it is. Anyway, let's take like a 1 minute break. I'm gonna go get a little water, stretch my legs, and then we're gonna do some work. And Maybe it'll be like 2 minutes. We'll see. See you in a bit. Alrighty then. That was like maybe not even a minute. I don't know exactly. Hey, Mind Bill. Welcome to the stream. You missed the start, yeah, you did, but I think you arrived at a pretty good time actually if you want to follow along. So, long story short, I have a hot reloading working, like on a sort of fundamental level. And I can hot reload things here. So again, if we go and have a look here at the carousel, and we change, yeah, that was quick. Yeah, it was quicker than I thought, actually. Let's see what am I actually? Yeah, okay, here we go. Name. You know, I can make that twice as large. I can build, and the building is kind of annoyingly slow. That's just SIG's LLVM backend being slow. So that's something that I'm gonna have to live with for a while until they get their own debug backend running on Windows. But anyway, we can hot reload this thing, and hey, we have new things on the screen, and it even works pretty well in game. But certain objects and types and components, they still break. And the very short version of the 1.5 hour lecture that I just had, which you can go and have a look later if you want to hear all of the issues that I've ran into. The very short version is that I have a bunch of function pointers that I need to patch up, specifically after the reload has taken place. And so, we're gonna do that now. We're gonna do some work, basically. And we're gonna start with the gripper truck, because the gripper truck is kind of easy to get actually breaking. So let's put a yeah, I want to plane and car here, but I'm thinking plane and car is a little annoying currently in its current state, because you're sort of like you're underground and then you have to fly up and spawn a car yourself. So let's make a few changes to that. Let's add test levels, plane and car. Did you solve the globals yet? I did, yes, I did solve the globals. Oh, we have some cars here. Ah. Yeah. So these guys probably just like, yeah, okay, they exist on layers that aren't... Yeah, okay. Yeah, okay. Wheel bug. That's probably that one, right? Next to the... Yeah. Still have PTSD from this thing because it was so annoying to fix. But okay, I just need to load some layers here from the script. It's fine. We're gonna work with this. Run script, wheel bug, and then we get one of these guys here. Okay, that's perfectly fine. Yeah. So here's the back, and then we have the front. And if we hot reload, the game crashes. Boom, immediately. Yes. Okay. So we're gonna fix this next, and then we're gonna probably look at the mother vehicle after that. Yeah. So globals. You can watch the full video if you want to, the full 1.5 hours if you want to. But the very quick version of it is that previously. Well, okay. First of all, I store everything on the heap now. I moved everything into such a form that I can store it on the heap. And so again, if we go and have a look at the main menu, for example, main menu, UI view model. All of the stuff that used to be global before, they're accessed using this getG. Let's make that a bit larger again. GetG, maybe this is large enough for you. Hopefully it is. Gets you a global data pointer, and then from the global data pointer you can do, you know, whatever you used to do before. This used to actually look like, you know, like that. This was my convention. I had a small G, and then the next letter was like a capital something. So it used to look like this. And so I just did like the bare minimum change that I could, and now it just looks like G dot instead, right? Oh, I'm undoing to like 2 days ago or something here. I should shut this down and open it up again to clear my undo stack here, so I don't accidentally undo something that I'm gonna regret later. I mean, I can see it in the Git history, but still. Like so. Yeah, so G dot something is how you actually access global data now, and each thing that has global data that previously used to have global data directly on the level, not the level, but directly on the file level, they now have this global data struct here. So you can sort of just work the same. It used to look like this, right? And then you had these like bars here, you know, like that. That's what it used to look like, but of course that memory would die when we reload the DLL. So now it's stored in a global data struct like this, and you can access that struct using this almost like breadcrumb sort of thingy where you go like okay, means.g, that's the library global data that holds everything, and then you go to UI manager. The UI manager owns the menu UI view model. The menu UI view model owns the main menu, and here we are. But instead of having to type this every time, I just made it an inline function. Inline is actually like a forced thing in Zig. It's not like in C++ where it tries to inline it, but it might not be able to inline it. In Zig, if it can't inline it, it's actually a compile error. So you're gonna have to take that away. So you can be pretty certain that this is gonna just access it directly, and then you get it through this. Yeah, using this thing, I can just, you know, keep everything on the heap, keep the heap alive across the DLL loading boundary, and everything's fine. But yeah, there were some wrinkles there. You can watch the beginning of the stream if you want to know more. Especially with like the Zig allocators kind of threw a curveball at me. With its levels of indirection, shall we say. Yeah, alright. So, gripper arm. Gripper truck arm. Let's fix that. So, wheel bug. Go here. Reload the game. Go to the gripper arm and try to move it and the game crashes. Okay, now we can see if we go here to the call stack that the thing we were trying to move is this steering values guy. So we have two propagated values here. We're gonna have to fix them both because they both use this set value changed callback. These guys, and I have a sort of a system for this now because I need to fix this in so many places that I have a sort of a system. Let's move this Excel here to the side so I can actually see it. Yep, that's good. I don't need to see it right now though. This is a component, and components have these magical functions that you can add and they get called automatically, such as pre-tick or update. Kind of like they do in something like Unity. If you add an update or whatever it's called, I think it's called update, to a mono behavior, it just gets called. No biggie. And I've extended that magical set of functions with two new ones. And I'm gonna copy this snippet out of my editor here just quickly. So on the border between the public functions and the private functions is typically where I place this stuff. Boom. So it's four methods. You don't necessarily need all of them, but I kind of typically just plonk them in here so that if you later need to actually reorganize something, it kind of looks the same everywhere. So these are two of those magical functions: before hot reload, after hot reload. Before hot reload does a teardown of the callbacks, which is here, doesn't do anything yet. After hot reload sets the callbacks up. And what would happen now then is that we go up here to the place where those callbacks are actually set. Right here. So it's these two guys. Yep. I'm gonna just cut those away. And I'm gonna go to onObjectCreated here and actually add a call to self set up callbacks. And in onDestroy, I'm instead gonna do teardown callbacks. That tends to be the safest way to do that. And then in setup callbacks, I call those. So what happens is that we normally run setup callbacks when we set up the object. Normally sets up the callbacks like this. Maybe we should put a comma there to break those up. Before we do any hot reloading, we tear down any callbacks that we don't want to have. You don't need to do it with these set value change callbacks. You just set a new one on top of the old one and it's fine. But some of those you need to actually tear down. So I typically have this here, like ready in place if you need to do anything. After the hot reload is done, you need to set them up again. So then it calls these two. Let's make sure this actually works now. So, wheel bug. Let's do a reload. Go to gripper arm. And look at that. The gripper arm works. So simple. I mean, some of this probably still breaks. If we try to move the truck bed, hey, we get a crash again. So, same thing there. So I'm gonna go to my Excel and mark those. So gripper truck arm component. We don't have any more than these two, right? Yep. That's fine. So the gripper truck arm component is done. Mark that on my list. And we can move on with our lives. And that's good. So then we have the truck bed component. And I bet truck bed has something similar. Yes, it does. Value changed callback, and it's just the one. So again, gonna take our little snippet here and plonk it into the correct place. Take that away from there. And you might be wondering, okay, why do I do the teardown callbacks if there's nothing happening here? Well, it's kind of just a way to, you know, keep myself from going crazy with this stuff, because I've been doing this so much lately that I'm kind of a little bit terrified of something going wrong. Of me just breaking this stuff. So I'd rather just have like a function that isn't necessarily called. It's gonna get stripped away by the optimizing compiler anyway. And then later on, if you need to actually put something in here, you know that, okay, the callbacks are created here and they're, you know, reset there or whatever for the ones that actually need to be reset. And if I just do that over and over, I should be good to go. Quite simply. Oh, I'm getting a phone call here. Let's do quick. All right. Sorry about that. Music is apparently fire. That's good. Excellent. What did we have? Oh yeah. I can show you here. Here's the Epidemic Sound. My stream number 2 playlist. I think I added this guy. I added this guy somewhat recently. Yeah, I gotten kind of bored with the music that I had previously, so I'm just like every now and then just dragging a few new songs into this thing. And it kind of tends to work pretty well. The interesting thing is that like you start to hear. I have a few tracks, I don't remember which ones of these. A few of the tracks that I kind of hear on like national radio here in Finland. Like apparently they use the Epidemic Sound service, or then they just happen to have like the same artists. Like several of these guys are being used on like news reports and things like that. So I'm like, whoa, it's interesting. Yeah. Okay. Let's have a look-see. Where was I? Where was I? I was here. Okay, good. So setup callbacks. That's all done. Truck bed. Right. So on object creator, this is typically like the safest place to call this guy. I could, like in theory, probably call it here already, because the steering values, propagated value has been set up here already at this point. However, if I create any more things here that need callbacks to be set up, then this obviously has to be called after those. So those higher tempoed songs are good once or twice a stream, rotating like 10 songs once per 5 stream, so they don't get stale. But boy, do they hit when they do. Yeah. I mean, the Epidemic Sound music is alright. Some stuff on there is really good. I kind of wish I could just. I wish there was a system that would just allow me to like play, you know, proper music on these streams. I would pay quite a lot of money actually for that opportunity if I didn't get hunted down and killed with a sword if I did that. There's just so much good music I would rather play for you guys. But Epidemic Sound is okay. It's okay. It's not bad. Yeah, I've been listening to a lot of like quite heavy stuff during this week with the hot reload. Speaking of music, could you let me know what music did you use at the start of your latest video with Web GPU? Let's see. I don't remember which one it was. And hey folks, Sebastian from Madrigal here. If this looks familiar, right? So that's the okay. That is a song that I use quite a lot because I like it. and it's called, and I have a license to use it, so I can play it for you guys here. It's not a problem. Let's see if I can find it. I think it's called A New Galaxy, if I remember correctly. Let's see, where's my blah blah blah? It's here actually. Yeah, Ben Sound. Yeah, Vital, A New Galaxy. Yep. There you go. Vital, A New Galaxy. I bought it from bensound.com, at least has it. And you can buy it, and then you can whitelist your YouTube channel for that stuff. And then you can use it in videos and whatever. Okay, I think we're done with the truck bed. Let's give it a try. Let's give it a try. Wheel bug. Okay, so can I lift up this thing and open its hatches? Boink. And then lift up the truck arm and close its was it the DNA? Sorry, I had a hiccup there all of a sudden. And can I now hot reload and then close all of this? So reset and then truck bed reset. Look at that. And now it works. Excellent. Yoink. Driver. Bonk. Yeah, like objects that you bring in. Oh, by the way, before I forget, truck bed component. Let's mark that on my Excel sheet. Truck bed is right there. Okay. So objects that you bring in and create after the hot reload, those are fine because the function pointers have been set after the hot reload happened, right? So now if I go and mess with this mother vehicle here, everything should work. So if I go to gravity crane and I move this guy around, everything is fine. Like so, but if I now hot reload, and now I try to move it, boom, immediate crash. And that is, let's have a look-see. Let's have a look-see here. Which one is it? It is here, and it's there. It's okay. Okay, this is a little more tricky, but not a whole lot. A little more tricky, because this sits actually in a type, in a struct that is not the component itself, but something that the component owns, called the telescopic two-joint crane arm. Telescopic two-joint crane arm has a bunch of propagated values, does it not? It has just maybe one. Actually, yeah, steering values. Okay. Set value changed, callback. Okay. Okay, that's fine. So what we will do in this case is go here to the same place between the public and the private functions, and you just plonk in those same functions here. Those don't need to be error returning functions. It's only that the component ones that need to be that. And then we have this. And I wonder if I should... Let's see, like, do we have any other callbacks here in this guy? No, actually, I wanna search for init.init without any sort of parentheses or anything like that. And I actually wanna take away a whole bunch of this. Like, you can do this in in Zig these days. Just dot something and it kind of figures out the type of it. Yeah, that's what we want to actually fix. This is the thing that's causing us issues. Yeah, here we can't actually take it away. We can't do that now. Just go const ori is dot init from, because it's like what it doesn't know what it is. So here we need to have quaternion dot, or then we need to do ori is a quaternion, and then now we can take that away. That would work, but that's nicer to do it that way. So that's fine. That's fine. We can get rid of that there. We can get rid of all of these. Yeah, this turned out to be just like basic code cleanup here. And dare I say modernization, because this didn't used to be possible in Zig before, but now it is. I've seen a lot of code recently in random repos doing var type is dot method. Yeah, exactly. And that is sort of preferable in some cases that you specifically declare the type, because there are these especially the built-in functions in Zig these days. They kind of determine the type that they, you know, cast to or operate on based on what you actually assign the value to. It's kind of a weird way of thinking about it, but it works really well in my opinion. Except in a few cases where it doesn't work at all, and then you need to have these ugly ass cases. So do you actually mine build? Do you do a lot of Zig? I kind of figured you as more of an Odin guy. But do you do a lot of Zig yourself, or is it just like a passing interest on the side of all the Zig that you're doing? Apply steering values. Yeah, I was thinking that. I wonder if this. I do not. I absolutely despise it. Okay. I see. Mine build is not an alias for ginger build though, is it? Like you're two separate builds. Or is it a rule that everyone named Bill needs to like Odin? Yeah, no, jokes aside, I don't think actually Ginger Bill hates Zig. I think he respects it, but of course prefers to use Odin himself. Yeah, okay. I'm curious, why do you hate Zig so much? I mean, I have my own grief with Zig. Don't get me wrong. I kind of like it though. So I'm always curious why people don't set up callbacks. Let's just put it there at the end. I'm gonna assume that's gonna be fine. because we are running this on both client and server. So yeah, that should be fine. That should be completely fine. And then we're gonna do the opposite here. Self tear down call. Whoop. Yeah, that should be fine. And then we just need to make sure we actually call these. So before hot reload, after hot reload. So where do we actually use this? I think it is in the... let's find out actually. Telescopic to gravity crane component, exactly. Here. Now, does this thing actually have some yeah, you can see it has the telescopic two-joint crane arm there, and it has the attractor, which I think also has a... yeah, it has a propagator value handle. Okay. Now, does this thing actually have a propagate? No, it doesn't seem to have a propagated value thingy. Okay, let's see. I also respect Zig, but they do a bunch of cool stuff that I like. But Zig feels dreadful to prototype with. Almost like Rust. A lot of S to something from something else. Error on unused stuff. Okay, yeah. Yeah, the S stuff is what I was just when I was talking about, like I kind of like the thing that they have this. What is it called? Let's have a look here. Let's have a quick look. So that I use the correct words for you guys. Oh, not that one. That one. So let's do, like, you know, PTR from pointer from int. Rip. So yes, this thing. The return type is the inferred result type, right? That thing is oh, did I not copy that? I'm just bad at my job again. PTR from int. Let's find that again. So you can see, okay, we can find it nine times here. Bitcast, enum from int, errorcast, floatcast. All of this sort of thing. So if you don't actually know what something is going to be, so tear down callbacks right here. So we have like const. I don't know. I is 1 2 3. That's a comp time int, right? And then we have const f is, you know, float from int I, right? If we try to use this, it goes like, oh, I don't actually know what you want here. So what you can do is you can go as f32, and now it's happy. Now we know, oh, okay, that's an f32. And this is of course super annoying, so you shouldn't do that. Instead, what you should do is, in this case, is just make that an f32, and now it's happy again. I do agree on two things that you said, though. The casting is a bit annoying, but they have relaxed that in the most recent versions of Zig. Like, I think, for example, that if you do, let's see if I make sure I'm not talking out of my ass here. Let's do again int 1 2 3. That's a compile time int, and then you do int const j. Let's make it the u32 is I, right? And then you do const k is u64. Like previously you couldn't assign j to k here, but now you can, right? If we compile that should work. Oh, okay. Whoops. I did exactly the thing that I wasn't supposed to. Let's Let's look at what it used to be. I did exactly the thing I was not supposed to do. 823, okay. Right, that's a vector 2. Yeah, okay, I could have... if I just took a moment to look at what those parameters were, I could have figured that out. But yeah, this kind of thing now works. Like you can just assign a U32 to U64 and it works. This didn't used to be the case. You used to have to do int cast here, like this. So it seems that they're coming to the realization that yeah, some of this explicitness is kind of like maybe not all that good. The unused, like this thing is kind of annoying. Yeah, I agree. It's kind of tricky actually to do with ZLS correcting it for me. I don't know. I've looked at this, you know, for long enough that I've kind of gotten used to ZLS fixing those things for me, and you know, occasionally it has actually, you know, saved me from some embarrassing bugs. Because you see like a one of these guys, autofix, that ZLS adds for you, and you're like, huh, why is that autofix there? Did I not use the thing? And then it turns out I'd used the wrong value somewhere. So I hated it to begin with, but I think it's like a tooling thing, at least for me. You know, with good enough tools, it's actually kind of nice. At some point, the build system accepted some anytype parameters that were impossible to figure out what I had to pass. Yeah, that is annoying. That I fully agree with you. There are some things in some of the APIs where you have a function which is like you know something, and it takes you know, it's called like param and it's called anytype. You know, and then it does something with it. And then you're like, okay, I have like what am I supposed to, is that supposed to be a value? Is it supposed to be a pointer? Is it supposed to be, what is it supposed to be? So what I typically do instead is like, you know, I do this, I do something too, and then if it takes, you know, anything, I make it a t, I make it a type, and then the param is like a, you know, like a const pointer to a t or whatever. Oh. And that's not how you make a const pointer in Zig. That's how you make a const pointer in Zig, right? To like make it a little more sort of make it a little more kind of clear what you're actually supposed to pass here. Even though in some cases you wouldn't really have to do this. You could just use an anytype. Anytype is kind of like, yeah, it gives you nothing. It's like, yeah, whatever, man, just give me something. Sometimes you kind of have to use it, but like, kind of try not to. Just read the code, man. Yeah, that's true. I will give them though that I think Zig's standard library is the easiest thing to reason about of everything ever. I think it is the most clear thing. It doesn't mean that like the stuff in there is simple. Like the code isn't necessarily simple. The code can be actually kind of complex. But I think if you find a function that you want to use and you're like, what am I supposed to do here? Yeah, you kind of just like, you can typically figure it out. There was one function just the other day that I was super confused by. What was it? Let's have a look. Was it the IO maybe? The IO thingy? think it might have been the IO. Init IO. No, it's not that. It was something else. There was something that I was wondering about, and I actually asked on the Zig Discord, like, what are you supposed to pass here? And it was kind of like right there, but the syntax was weird. I've never seen syntax like that before. Anyway, you sometimes you run into things where you're just like, what is this? And of course the documentation still isn't very good. You kind of just have to figure it out a little bit. What I'm super impressed with these days is C3. Of course, I did the C3 stream or streams, and I like the language a lot. Seems like a very cool language. I did not like the tooling, as was kind of suggested to me that the tooling isn't really where it needs to be, and yeah, it isn't. But maybe it could be someday, and then it could be a very nice language. Okay, I'm gonna go back to this now here, and let's have a look-see what we have. So I think this gravity crane component is actually not a very long file. It's not even 500 lines. I think this thing doesn't have any callbacks in it at all. It just has these two guys, this arm and this attractor, and they have callbacks in them. So we need to fix them up. What is that? Gravity crane tube. What is this? Why don't I understand what this is? Tube. What in the... What in the world is this? Gravity crane tube. It uses a curve path. This is weird. Render object. Do we have a mesh here? Mesh source. Alright, we're creating the mesh at runtime. I don't remember what this is. Maybe when Zig reaches 1.0 I'll change my mind. Yeah, I mean, you don't have to change your mind. It's perfectly fine. Luckily we have options these days, right? It's kind of like the same thing with that NVRHI video I made. Like, people got super upset and mad. Like, of course they did. I was kind of prepared for that. But I was trying to calm them down in the comments there. I'm going like, hey, it's fine. If you want to use WebGPU, use WebGPU. It's fine. I'm like trying my best not to bash it here. I'm just explaining why it didn't work for me. Yeah, clearly some old copy-pasted code. I would never write this anymore. I used to back in the day, though. What is this tube thing? Like, it renders some stuff based on a sample points curve path calculator. Where's this curve coming from? I wonder if this is something that I had sort of... I was thinking of doing and then I didn't do it in the end. here we're debug drawing something. What do you think will actually happen if I re-enable this thing? And then I need to probably do the tube update here. What is going to be rendered? I'm a bit scared. What if it's a what if it's a penis? Oh, what happened? Oh, did I? I'm still running it. Am I? I think I am. Mother. Ah, it's that thing. Oh, okay. Yeah. It's a tube. Of course. Okay. Yeah, I was just confused. Yeah, okay, that thing actually, like, it kind of deforms a little bit with... Okay, well, that needs to be there anyway. It's not a... It's a... I didn't remember I had to write this much code to make that happen. Okay, anyway, I don't think that thing has any callbacks. People are weird. Well, people are conditioned to being angry at things randomly. It's actually a discussion I had on the Discord. You should all, by the way, join the Discord if you haven't done so already. Link in the description and in the chat and everywhere. There was a discussion on the Discord about that video and the wild comments there, and yeah, I said that, like, I kind of knew going in that it was gonna be a little bit of a shit show, because it was a video that I kind of had to bash WebGPU a little bit. Like, just, I had to, like, explain, hey, there's this thing I don't like about WebGPU, and there's this other thing I don't like about WebGPU. And I kind of don't like making those videos. I'm much more excited about making videos where I'm like, hey, look at this shiny thing here. This is cool. I like this. And that video had like a little bit of both, which made me kind of hesitant to make it in the first place. Because, like, while I was excited about NVRHI, and I still think it's pretty neat thingy, I had to, like, be a little bit negative about WebGPU. Otherwise, it, you know, wouldn't have made any sense. And... especially if you're negative towards something, you're not like you're almost like not allowed to have an opinion on things, unless it's like, you know, hip and in vogue to be negative about things. Then you're definitely allowed to be negative about it, and then it's like almost required that you are. Hello, guest Leet I. Welcome to the stream. So yeah, not sure I would say that people are weird, but it's sort of like the internet culture is weird sometimes. And I was trying my best to go like, no. WebGPU is still fine. I'm glad it exists. I'm glad it's working out for you. It didn't work out for me. What language is that? This is Zig. This is Zig, and it's the language that the gameplay code for my game is written in. Rightio. So yeah, we didn't have any callbacks there. So basically we just have those are all fine. Those are all fine. Those two have things that need to be re-hooked up, and then those are all fine. And just a quick look through here. I don't think we have any callbacks here in this code either. Yeah. That's all fine. Cool. Then we have just the properties. Okay, excellent. So, let's go to the normal place, which would actually be here at the bottom, I think. And apply our snippet. I think actually I don't really need any setup callbacks or teardown callbacks thingies here. Instead, what I just need to do is to call self.arm before hot reload and self.attractor before. Oh, I don't have it there yet, do I? I don't think I do. That would be after. So the attractor is of type, what is it? Gravity crane attractor. This guy. Yeah, this one doesn't have it yet. So let's add it here. And then we should be good to go with this entire component. So what do we have? We have just a single propagated value. And we have a create function and we have a destroy function. And where is that thing actually? Oh! This thing doesn't have a... That thing doesn't have a call to set value change callback. No, it doesn't use a value change callback, so it's completely fine. It doesn't need those. Yeah. Yeah, we're done. Cool. So, I think if we go to gravity crane component, that should be all we need. Maybe we'll move... that's fine. Let's keep them where they are. So let's see if we can actually run this now. So my biggest gripe actually with Zig now, especially with this hot reloading coming into function, is their compilation speed. I want it to be faster, a whole lot faster. Okay, so yellow, hello mother. Now we can turn on the gravity crane. Cool. And let's do a hot reload. And let's look at this. It just works. It just keeps working. Now I bet that cargo crane, which is the other one there, I bet this guy breaks. Yeah, he breaks. Okay, let's see. Just typing again, because YouTube doesn't allow, I think, what? I learned all the C# from a website called W3 Schools. What do I need to learn now to become a master? Master of what? Master of puppets? Master of C#? What do you want to do? What do you want to do with your C# knowledge? Regardless, I don't know. I have no path for you, unfortunately. Gravity crane component. Let's mark that as being done. There we go. To become a master in C#. Okay, well, I should tell you I'm not a master in C#. I've been writing C# for over 20 years, believe it or not. I started writing C# in 2003 or something like that. And around 2005, it was Visual Studio 2005. Around that time, I kind of just stopped learning new things and just like got kind of complacent with what I knew. So recent C#, like the thing that's very sort of functional and all of that, I don't really know that all that well, so I've written a whole lot of C#, and there's a whole lot of C# actually in this code base as well, if you count the tools, but it's actually pretty old C#, like old style C#. Actually, look at some of it here. You can see this is a pretty massive solution actually, and some of these things in here are actually pretty massive. But yeah, it's very sort of basic C#. I bet if you've gone through some recent course on C#, you probably know a whole lot of stuff that I don't even know. So unfortunately, I don't really know what to tell you if you want to become a C# master. My general advice, though, is just build stuff. Doesn't really matter what you build it with. But if you like C#, then just build them with C#. That's perfectly fine. Just build things. Build things you want. Build things you need. Build things you think are cool. Build lots of things. That gets you experience. And before you know it, you will be some kind of master. Right, so the cargo crane uses a cargo crane component, unsurprisingly. Does this thing have a propagated? No propagated values. Okay. I also don't think this necessarily has any other callbacks, but it has an arm. That's a 2-joint crane arm. It's not a telescopic 2-joint crane arm as the gravity crane has, but it is a crane arm, and this guy has a propagated value handle right there. Yes. Then it has a cable magnet assembly, which I bet also has some propagated value handle. Yes. I'm kind of thinking that this guy doesn't necessarily have any value changed callback either, though. No, it does not. So that's easy. That means that we basically have to do the same thing in same thing for the cargo crane as we do for the gravity crane. Let's quickly have a look through this and see if we spot any callbacks. Sorry, I'm kind of spacing out here while I'm talking. That line is a bit long. Let's shorten it a little bit. Yeah, I think we're pretty good. I mean, this is kind of similar to the gravity crane in many ways. The cargo crane is significantly trickier to actually make, though. It's kind of ironic because it's sort of like a magnet crane that we actually have in real life. The gravity crane is not something that we have, at least yet. So it's very much high-tech and sci-fi. But actually making one of them in code is much easier than making the cargo crane. So let's add these guys here. And we don't have these, but we will have arm dot or self dot arm dot before hot reload. And then we will have self dot arm dot after hot reload. Like that. And then we go into the arm, 2-joint crane arm. Where did we put this? Yeah, okay. I think we can actually probably just copy all of that. Let's see. Put that off to the side. Probably here. Oh, my AC making sounds in the background. If you're wondering what those weird sighs are there. Okay, steering value. Is that like exactly the same that we have here? I bet it is. Yeah, it's exactly the same. Cool, cool. Let's keep it like that. That's fine. And then we need to do setup setup callbacks. And again, I'm gonna do it here at the end. And then I'm gonna do the opposite here. Self tear down. Oh, tear down callbacks. Actually, we do have a way to do this tear down here. I didn't even remember that was a thing, but yeah, you can actually set it. Set it like that, or clear it rather. It's not really something you have to do in a hot reload, because like nothing is actually going to be running in between we do a hot reload. Like we start a hot reload and finish one. So you don't really need to clear it first just to set it later, but that looks hella complicated. It's annoyingly so, yeah, in some cases. You want to keep your code as simple as possible, generally. And I think I might be over-engineering some things sometimes, yeah. Okay, let's see. Hot reload. Rips. Cargo crane. Look at the cargo crane. It's working. Spawn a dynamic crate number 1. Let's try to lift it up. See if it works. Let's try to swing the cable there. Look at that. It works. Of course, we're kind of just like seeing that stuff isn't completely broken now. It's kind of fun. You can like drag this with the other crane, and like within the influence of that, we've got to sort of like yank it towards itself. Like that, and then you can drive around with them like this. But I'm planning to finish the project. I'm hoping to actually release this game this year. If you think this looks cool, then there are 2 things you should do. First of all, you should check out the link in the description, or in the beginning of the chat there is a link to the Steam page where you can go and wishlist the game. And you can see there that the release date is tentatively set to this year. We'll see if I can manage that, but that's the plan. The other thing you should do is you should join the Discord, where you can first of all play Pre-Alpha 3, it's a slightly older version of this game, and the demo mission there. And you also get to follow along with everything that's happening. And just like discuss general development and everything. We're a pretty chill bunch. So I do recommend doing that. This looks cool. Sometimes you can do things like this. This is just fun. This is just fun. Sometimes the resolution isn't quite high enough, but like you can do things like this. Just have it hanging on the other crane there. I just think this looks nice. It's on my wish list. Hello, 25th, by the way. Welcome back. It is okay if you delay it. Yeah, well, thank you for the go ahead to delay it. I'm not sure. I'm not sure I can delay it much longer. I've been working on this for so long. I may have to, but like for my general sense of, I don't know, well-being, I should really try to get this done. Do I use asserts? Boy, oh boy, do I use asserts. How many asserts do we have in this? Yeah, we have 391 asserts in the SIG code. And in the basis code, we have basis assert. How many asserts do we have? We have 3,996 asserts in the C++ code. So yes, I do use asserts. Sometimes to a ridiculous amount. Hey Jake. Are you gonna stream today? Or tonight? Or I don't know, what is it morning where you are? Probably earlier than here anyway. Okay, let's that was it. That was it for the mother vehicle. Let's do one more at least. Try to figure something out. Unstuckifier seems to be using a propagated value. Jake is going live shortly. Everyone, when I need to stop in about half an hour or so, you should all go and join Jake's stream. Jake is also making an indie game with custom tech, and it's going to be awesome. So do go hang out there and see what's happening on the tropical island. Let's see. To be fair, the next game will come out 10 times faster. It's a process. Yes, the thing is that I've shipped games before, not really by myself, or at least, well, I've shipped some prototypes and things like that, but I haven't really shipped a proper game by myself, but I've shipped probably like 15 games. So, I don't know, I don't know if this was my first game, then yeah, the next one would probably be faster, but after 15 games, you'd think that like, I would probably have it nailed down by now. Anyway, let's see. Unstuckifier component uses propagated values. There's one. Yeah, it has just one. It has the state. Value changed callback. Yeah, there we go. Okay. That's where we're setting. What is the goal of this game, by the way? This is a you know what? I'm gonna be lazy. I'm gonna be lazy here and just go to the Steam page. Let's see. Hub admin. Come on. Yeah, you get to see some admin stuff here. This is not what I wanted to go. Steam traction point. You can just Google Steam traction point and it gets you there. But yeah, this is kind of a road trip, a sci-fi road trip of sorts. Oh no, not the audio. Sorry about that. Bye bye Arcane. See you next time. Thanks for today. Yeah, this is kind of a sci-fi road trip of sorts where you have to like navigate environments and sort of a chill kind of zen puzzle exploration sort of thingy. No combat or anything like that, at least in the base game. There is already pretty substantial modding support for the game, so you can just like make a minigun if you want and blow things up. That's completely fine. It's supported. You're gonna have to code that yourself though. It's not like a put together things from like blocks. You actually get to write code on the same level as I do. And then there's like a sandbox mode where you can specifically try out those things. So do check that out if you think it looks cool. It's like a combination of Astroneer with a driving game. Yeah, I don't think the depth is quite on the Astroneer level, but I appreciate the sentiment. Thank you. It is also significantly more story-driven than Astroneer. Although the the sandbox essentially has like limitless depth, right? Because you can just make your own stuff and then just mess around in the sandbox mode. And that obviously isn't story-driven, but the main game is sort of like a story-driven somewhat linear ordeal. Let's try the unstuckify component before we try to fix anything here. Drivable block, non-drivable block, wheel bug. I think I can probably, yeah, I can warp to that. Rip. So we could code a mod that destroys the game in a server. You can definitely destroy things here. Yep, you can do it. You can do it. This is not a multiplayer game though, so no worries about that. Oh, you meant the art style. Yeah, that's fine. No, absolutely. And yeah, our Astroneer is a beautiful game, so I appreciate the sentiment. Yeah, you can see this vehicle uses the simplified wheel model, so you can sort of like get your wheels stuck between those things like that. If we go and switch to that guy. Hello. Let's see if we can come down here without getting stuck. Yeah, we can. Go away. Go away. You're in my way. You can actually just lift those guys up and put them in the back of this vehicle if you want to. This vehicle uses the more exact tire model, which means that it doesn't fall through those cracks. That's sort of a design decision that I made, because the simplified wheel model allows you to like just cruise along at very, very high speeds and you don't really get stuck anywhere. But okay, now if we activate the unstuckifier, as always, you get sort of pulled back the way you came. So what now happens then if we do this and then we do a hot reload and then we try to do, yeah, look at that. Immediate crash. And that is because we're setting the propagated value well, I'm pretty sure it is that one thing that we looked at, so let's just go and have a look there. Unstuckify component. Let's get our little snippet going. Oh, by the way, this stream is all about the technical side of the hot reloading business. If you want to actually see me use it for things, then we don't need that there. Then stay tuned, because I have on my to-do list a task to make a camera shake effect. I need that for several reasons. I need a camera shake effect, and you can actually just get rid of this component completely. Let's comment it out. And yeah, so I was thinking that would be a pretty good sort of like test piece. Teardown. I say test and I write test, but teardown is what I wanted. That would be a pretty good kind of I don't know, test bed, test case for this thing, right? To see how well it works, and actually develop something with hot reloading. So stay tuned for that if you want to actually just like see it being used. I'll be sure to watch these videos back to back while I code my own stuff. Her voice is soothing. Well, glad to hear it. That was maybe a little unsettling though. Okay, let's see. Now if I can just use this guy. Oh, but we need that other layer to have those things to get stuck on. Drivable block. Of course, I don't really need anything to get stuck on. But it's always nice to get stuck on something if you want to try out the unstuckifier. So now it works. Oh, hey, get a little bit of physics wiggliness. Yeah, so now it works. Now it no longer crashes. That's nice. And yeah, there's some physics wonkiness with this. That's kind of just par for the course. Of course, these objects are kind of wonky as well. Just like these super hard boxes, kind of tall boxes. You can't actually really get up there. You have to lift up the arm, and then I probably can't even. Can I do it? I don't think I can do it. Nah, this is not an all-terrain vehicle like the Scout. With this one, I can get up to that. Even that last one there. It's kind of tricky to stay there because it's so high. Oh, maybe I can't get it. Oh yeah, you can. You sort of can. You can see that it's just suddenly glitching through the entire thing. You must be from Finland. Well, guilty as charged. I can hear the Rally Englanti. Rally Englanti is it's a concept that describes like a sort of like from a certain perspective kind of poor English, well, especially the very, at least to Finnish people, very sort of easy to identify pronunciation of things. We're sort of pronouncing things as if speaking Finnish, even though I'm technically a Finland Swede. I kind of have the rally Englanti spirit about the speaking. But yes, I'm from Finland. Yes. Gotta drop off. Well, have an excellent stream, Jake. Hopefully you inherit some of my viewers when I need to stop in a bit, but I will continue going for a little bit. I will take like a 5-minute break though. I will keep going for a little bit further. This is going pretty well, and I just keep ticking off these bugs and fixes one after another here. So I'm gonna keep going for a little bit further, but I need to call my kids and tell them to get ready for bed, essentially, because I'm actually not in the same building as they are currently. So give me 5 minutes to do that, or maybe like 3 minutes, and then I will be back for maybe like another half hour or so. So see you in a bit. Alrighty then, we are back. Okay, let's see. As an American, I had a cringe moment where I had a I want to go to Finland moment, so I tried learning a language. Oh no. Yeah, Finnish is weird. Finnish is a weird language. Keep in mind that my native language is actually not Finnish, it's Swedish. And so I fully I fully understand your confusion. I thought with my Spanish and French experience prepared me. No, it really doesn't. Finnish is such its own thing. If you're Estonian or you're Hungarian, maybe some other languages as well, you might have a little bit of an edge. But like Germanic or Hispanic languages, nah. It's completely different. I want to add that it was most of the characters like or we don't have that other one. We don't have the E with the umlauts. We have like I'm just gonna type them in the chat. Like we have Ö and Ä look like that, and then if like me you're actually speaking Swedish, then you also get O, which is like a Stargate A. Yeah, we have those, as do most Nordic languages, and like Danish and Norwegian have other ones. But yeah, I'm basically like trilingual, if you wanna, if you count my English as being good enough to be considered a language I speak. But yeah, Finnish is weird. Coming from a Finn. Very strange language. Very sort of systematic though. You speak it just by like every letter has a sound. And then speaking Finnish is basically just like making those sounds one after another, exactly how the word is spoken or sorry, written. Which, like, there's almost no exceptions to that rule. There are no like silent E's or S's or whatever crazy exceptions there are in English. It's just like no, just make all those sounds one after another, and then you're speaking Finnish. Okay, Unstuckifier is done, right? Let's give it one more try. I'm gonna I got let's do a few hot reloads, why not? Yeah. I got kind of paranoid that I didn't actually do a hot reload, but it looks like I did. Yeah, that works. Let's mark that as done. So what would be the next one then? Gripper arm. I'm pretty sure we did the gripper arm. No, we did the gripper truck arm. native Swedish people have a distinct accent when speaking English. They do, yeah. Absolutely. I mean, that is sort of like just, you know, audibly. Not talking about like words and phrases and like differences like that, but just audibly the difference between a Swedish Swede and a Finland Swede is that Finland Swedes speak with a Finnish accent. So I have basically a 100% Finnish accent. I'm sure some Finns would disagree, but it's not like it's not the Swedish accent. I can kind of speak Swedish if I really try to, but well, yeah, I don't do that by default. And of course, like Sweden also has a lot of different accents, just like Finland has, and like every place ever has. Okay, let's do the gripper. We did the gripper truck arm. Let's do the gripper arm as well while we're at it. It should be a very simple little thing to do. So the gripper is actually an old vehicle that is just completely sort of placeholdery and weird. The gripper is right here. This weird looking forklift thing. So this thing has an arm that looks like this. It can be moved. Oh, it actually can't be moved back and forth. It can sort of be moved back and forth along this axis as well. I just took those inputs out because I needed them for other things. But yeah, this thing can like lift stuff with this, kind of like the gripper truck can. The reception to this vehicle was so poor though when I originally launched the game, or the pre-alpha 1, that I figured, nah, this thing needs to go. Or it doesn't need to go, but it needs like a better... So this is like the new version of it, this thing that's almost like a truck. And now if we move this thing, it will probably crash. No. No crashing. Okay. What? Did I hot reload? I think I did. It does not crash. Oh, it's this thing. Right. Gripped object name hash. Is that the only propagate? No, we have a whole lot of them actually here. But we don't have more than one value changed callback, though. That's almost kind of strange, isn't it? Because we have two here. What do we have? We have steering values, and then we have the gripped object thingy. But I bet if we actually... try to lift something here, let's put a power cell down. And now if we try to lift this thing, it will probably crash. So we need to fix that. I'm not sure if this vehicle will actually get used for anything, but it's here and it works, so I'm gonna fix it so it works with hot reloading as well. So let's do rip. Wow, it just works. That's peculiar, but but the fix is also easy, so I'm just gonna do it anyway. Maybe I'm not using this component right now. It does not crash, I wonder why. It crashes, I wonder why. Yeah, there's a saying that the only code that is scarier than code that doesn't work when it should is code that works when it shouldn't. And that's what we are seeing right here. So we don't have those. Oh, I didn't copy that one. Yeah, that's why it's weird. That's why it's weird. Right there. Okay, so we have this guy. And we're gonna do self setup callbacks. Self teardown callbacks. just set it up there. And I think we're gonna basically do that. I kind of like this idea of clearing the callback. It might actually go into... No, it actually doesn't. This is a very simple... Yeah, this is a very cheap thing to do. So I like it even more. Now I like it for real. Yeah, we don't have a lot of viewers today. Actually, far less than I was hoping for. That's fine. It's been a pretty chill stream. Some good discussion. I have to say though that every time I kind of think that okay, I know how to get, you know, I know when to stream and what to stream to get like a little more viewers and whatnot. It never works out how I expected it to. So sometimes I'm just like, nah, fuck it. I'm just gonna stream. It doesn't matter. I have this thing that I need to you know, work on or whatever. I'm just gonna stream it. If I get a single viewer, get something out of it, that's fine. Then I get like 20 or 30 guys just going like, oh, what is this? Alright, let's see. Hot reload. Burp, 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 burp. Well, at least now it works. Maybe I could have crashed it somehow without that fix. I don't know. It's been a long day. My brain is kind of fried a little bit. Going to see Jake and see what he's doing. Do that, yes, absolutely. And maybe we'll see each other later. Rightio. So that was that. Do we have any of these other? A whole bunch of propagated values here. Vertical arm angle. Yeah, this guy doesn't... Oh, this is just horrible code. There's like almost 1,000 lines of code in this single file. I'd like to believe the Ripper truck arm is a little shorter. Well, it's almost not shorter at all. Okay then. Okay then. Anyway, doesn't look like any of these are using callbacks, so that's good. Yeah, just this one. Cool. Cool. That looks good. So this is basically done. Shorten some of this again. Rightio. I think we're gonna do maybe one more, and then I'm gonna call it for today. I've been doing this for well, it will be basically 3.5 hours at that point. I think that's quite good. Quite a good place to call it a night. Let's see. We have teardown and we have setup. Teardown and setup. Yep, that looks good. Okay, I'm gonna mark that off my list. What do we want? Toggle feature. Toggle feature component could be an interesting one. This would actually probably have us do a little bit of scripting actually to test this out, but that could be fun. So let's do that. Let's start Or let's let's end today's stream with creating like a small little reproduction case. So we have plane and car. Whoops. Yeah, there's a little choppy while it's rendering this. What are they called? Thumbnails. So let's call this new layer that we're adding here toggle feature test. And then we'll add a mother, which is currently the only vehicle in the game that has a toggle feature. And basically what you can toggle is which of the cranes you have enabled, because there's sort of things that you're gonna be sort of unlocking them throughout the campaign here. Why don't I have script code property, good. Why don't I have a that's strange. I wonder if we have a new bug here, quite simply. Right, so here we have script code, script opening editor, and it kind of shows it to us here, like this. I do have some scriptable things here though, but they don't actually show up. Toggle feature component, created on client and server. Yeah, it should show it to us as a button here. You can click and show the code, and then it should actually show the code. It doesn't do it here. That's strange. The AI brain is scriptable, and the toggle feature is scriptable. They should both have those buttons. They don't. I wonder if this is something that broke with the Zig version upgrade. Peculiar. Okay, looks like we're gonna have to do a little bit of bug hunting here to start with. That's not what I wanted to do, but oh well. Can't be helped. Let's go into the component factory. And actually it's here, it's components. And then we'll find the init component type. And we should see factory is scripted right here. So I'm gonna print here. Is scripted, and then we'll print I think the type name. That would be type name of T. Isn't it T? Yes, T is what it's called. Else. Just do it like this, very basic. Is not scripted. And then we just run the game. So what do we have? There's the AI brain. One. I'm probably gonna have to copy this. Something like that, right? We can search for it. Brain. Yeah, AI brain is scripted. That's good. And then the toggle feature, yeah, it's also scripted. Okay, so that at least works. Wow, that's peculiar. It it doesn't really surprise me though that we have something like this, because I upgraded my Zig version from a pretty old one. Well, it was from like November or whatever, but when I went to like a 2 or 3 months more recent version about a week ago. And so just like in the last stream where we had some Zig related issues, it is possible that we have some similar thing here. Or it might be that it's something to do with this pretty large refactoring I've had to do for these hot reloading thingies to work out. But anyway, I'm probably gonna have to look at this and see what's up. But I don't think that's very interesting content for you guys, so we're gonna call it quits for today. Thanks to everyone who came to hang out. If you want to help out the project, do and go and check out the Steam page and wishlist the game. If you want to play the game, you know, today, you can play pre-alpha 3. All you have to do is go to the Discord and look at the instructions on the announcement page, and you will get a Steam playtest key from there. And yeah, that's basically it. Have an excellent rest of your weekend, and see you next time.